All right, so this is the last video of this series. Okay, so what I've tried to do is show you a variety of different projectile scenarios and give you all the tools that you're going to need. I mean, there's hundreds of different scenarios. I can't obviously do an example for each one that's out there, but this should give you enough experience seeing them that you'll be equipped to handle pretty much anything that comes at you. Okay, so in this one we got a couple of weird things going on. So we're firing our projectile. Boom, there it goes. Okay, we're firing in our picture, it's the opposite direction, so it's like, why are they making that necessarily complicated? But they did. It's okay, we can handle it. They don't actually give us an angle. We kind of have to assume that it is parallel or perpendicular to the surface. All right, so it's firing straight up from the sense of the surface, just like that. And our job is to figure out how far down the hill does it go. Okay, so here we go. Okay, now, like I suggested before, great place to start is with your initial X and initial Y components. Okay, so let's go ahead and do that. So I need V naught X. Okay, it's going to be, we're going to have to say here, minus 20 times the cosine of the angle. And then V naught Y is equal to 20 times the sine of the angle. Okay, now, what angle are we talking about here? Okay, so this is 90 degrees. And we've got this 3, 4, 5 relationship to define our other one. And so what you really have to do is take your 3, 4, 5 triangle and pivot it around 90 degrees. Okay, so when you do that, sines turn into cosines, cosines turn into sines, that sort of thing. So what we have, let me kind of inflate this to get a better look. What that means is when we put this on here, our trajectory here, if we consider that to be the hypotenuse, okay, what we're looking at is something like this. Oops, let me do a little better job there. Here, okay. So this becomes the 4, okay, sine becomes a cosine, cosine becomes a sine, this becomes a 3, and there's our 5, just like that. Okay, so in our scenario here, then cosine theta goes as 3/5, and sine theta goes as 4/5. Okay, so now we can go back to our relationship over here with our x and our y's, and what we're going to have is minus 20, and cosine we figured out was 3/5, which means that's going to be minus 12. Okay, 20 divided by 5 is 4. 4 times 3 is 12. And then on this one, we're going to have 20 times 4/5, which is going to be 16. Okay, so now we got those two components. All right, woohoo! So no matter what, at this point, we could feel like, okay, well, we've gotten something done. Okay, all right. So what we're going to do here is we're going to look at our X and Y relationships, which is, kind of what we've been learning how to do. And so our X relationship, okay, any displacement in X is equal to V naught X delta T, okay, which we know, let me go ahead and put in what V naught X is, which is minus 12. So minus 12 delta T. Okay. And our Y relationships, we use Optimus Prime Light. Okay, we're going to have V naught Y delta T minus a half G delta T squared. Okay, and again, let's go ahead and put in our number. All right, so that's a 16 delta T minus a half delta T, G delta T squared. Okay, just like that. All right. Now, At some point, we're going to be way down here. Okay, understand that. So there's some x final and y final, and r is going to end up being the square root of x final squared plus y final squared. Okay, so if we can get those, then we're in good shape. So if we come up here and we call that 0, then our delta x is the same as x final. Okay, so that works out pretty good. Okay, however, I've got 3 unknowns right now, right? I've got delta x, delta t, delta y. Okay, I only have 2 equations, so that means algebraically this isn't going to work. I'm going to need some more information. Okay, well, that, again, as you probably can guess, is going to come in the form of some kind of constraint, okay? So we've seen that before. Now, our constraint in this case is this line right here, okay? And along this line, all right, we know that y, or we can call it delta y, is equal to 3/4 of x. Okay, so 3, 4, rise over run, there's my slope. Okay, so I can use that as the equation for my line. Okay, now if I use that, I've got 3 equations to go with my 3 unknowns. Boom, and I can be in business. Okay, so I'm going to take this relationship and I'm going to stick it up in here. Okay, so that becomes 3/4 delta x is 16 delta t minus 1/2 g delta t squared. All right. Okay, so far so good. But then I'm going to take this information up here and I'm going to put it in right there. Okay, so another substitution. So now I have 3/4 of delta x, which is minus 12 delta t. 16 delta t minus 1/2 g delta t squared. Okay. Look at that. Now everything is reduced to a single variable, delta t, a single unknown. Okay. So if we kind of look at this just a little bit more, then I'm going to have here minus 9 delta t is 16 delta t minus 1/2 g delta t squared. Okay, there we go. Boom! All right. So I'll let you finish that up. All right, we've got the biggest, hardest part of it done there. Because what that's going to do for you is it's going to allow you to get your delta t. Okay, so delta t equals some stuff. Once you have that delta t, plug it back up in here. That's going to get you your delta y. Plug it in here. It's going to get you your delta x. Then you're going to take those 2 values and drop them in right there. Okay, there we go. All right, now let me erase or undo some of that to make a point, special point for you here. Okay, I want to look at this part right here. Okay, so where and why did that come into play? Well, remember that was the 3rd relationship that allowed us to connect our delta x and our delta y. Okay, that's what that did. In this particular situation, that relationship was that straight line. Okay, but it could have been anything else. All right, we might have had some kind of really bizarre function. Let me get a fun color here. All right, some kind of function that maybe it was a parabola. Okay, or something else. We don't know, okay, what it was. But whatever it is, okay, whatever it turns out to be, we're going to have some y is a function of x. Okay, and then whatever that is what we put up in for here. So we would have 16 delta t minus 1/2 g delta t squared is equal to whatever that is. Okay. Then, just like before, we took this and we substituted it in right there. We would do the same thing. We would take that relationship and drop it in over here. Okay. So they could throw anything they want at us. Something going uphill and curvy, whatever. Okay. I mean, now they could throw something at us that would just be algebraically yucky. Like maybe they did, maybe our function was an exponential. Okay. Maybe this was, 3e to the minus 2x. Okay. Now that's just going to be yucky. That would just be mean, because then that would mean I'm going to have something like this. 3e to the minus 24 delta t. And then I've got to extract the t's out of there algebraically somehow. And that's not going to be fun at all. Okay, so that would be that's an example of what we would call a transcendental equation, and we'd have to use some special techniques to try to solve that. Okay, but my general point here is that whatever equation that they want to throw at us, okay, of this form right here, all we need to do is tuck it into this spot right there, boom, and we're good to go. Okay? There you go. Okay, you got lots of tools in your toolbox now for doing projectiles.